So you know how I was talking about that async API we're working on? The callbacks can really get out of hand.
Yeah, it feels like every function needs another callback, and then another. It's hard to keep track.
Exactly. And when you start nesting them, it turns into what some people call callback hell. Imagine trying to debug something buried 5 levels deep.
That sounds terrible. How do you even approach fixing that?
Well, first step is recognizing the pattern. When you see yourself adding a new level of indentation for each new operation, that's your red flag. You need to refactor to use promises or async instead. I'll wait syntax instead.
But isn't that just trading one problem for another? What if using promises or async await also gets complicated?
Good point, but the key difference is readability and maintainability. With async await, you write code that looks almost synchronous, which makes it easier to follow. Plus, error handling becomes cleaner too.
Still seems like a lot of work up front to rewrite everything.
True, but think about the long-term benefits. Cleaner code means fewer bugs, and less time spent in meetings trying to explain tangled logic. Have you tried refactoring a small part of our current project yet?
Not yet, but I'll give it a shot. It just feels overwhelming right now.
Totally. Understandable. Start with the smallest piece you can isolate. Break down the big task into smaller chunks. Each little victory will make the next step feel more manageable.
Makes sense. I'll try breaking things down and maybe ask for help if I get stuck.
Great plan. Neil. And remember, there's no shame in asking for help. We all started somewhere, and sometimes even experienced developers hit roadblocks with async stuff, because it's tricky by nature.
Thanks for the encouragement. It does help knowing others struggle too.
Absolutely. Just keep at it, and don't hesitate to reach out if you need advice, or just want to bounce ideas around. Async programming has its quirks, but once you get a handle on it, it opens up so many possibilities.
Guess I should dive back in then and see where this takes me.
Speaking of tricky parts, have you run into issues with managing errors in those asynchronous calls?
Yeah, it's a real headache. Sometimes an error occurs, but I lose the context of where it happened.
Right? It can be such a pain. One thing that helps is using try-catch blocks within async functions. That way, you can catch errors and still retain the call stack context.
But doesn't that make the code harder to read with all those nested try-catches?
It can, but there are ways to manage it. For instance, wrapping your async operations in utility functions can help centralize error handling logic.
Like creating a generic error handler function?
Exactly. You could create a helper function that wraps your async calls and handles errors consistently across different parts of your application. This keeps your main code clean and focused on functionality rather than error management.
That sounds like a good approach. Any tips on how to implement such a function effectively?
Sure, you define a function that takes another function as an argument, runs it with await inside a try block, and catches any exceptions. Then you decide how to handle the error, log it, rethrow it after logging, or whatever makes sense for your app.
Got it. So basically abstracting away the boilerplate error handling.
Yes, exactly. And don't forget to pass along any necessary context to the error handler, so you can log meaningful details, or take appropriate actions based on where the error occurred.
Makes sense. I'll definitely give that a shot.
Perfect. And if you ever find yourself needing to propagate errors through multiple layers while maintaining context, consider using middleware patterns or context objects to carry relevant information throughout the process.
Interesting idea. I might explore that further too.
Definitely worth looking into. Managing errors well is crucial for robust applications, especially when dealing with asynchronous flows where things can go wrong at any step. Another tricky aspect of async programming is race conditions. Have you encountered situations where the order of operations becomes unpredictable?
Oh yeah, it happens all the time. Sometimes functions complete in an unexpected order, leading to all sorts of issues.
Exactly. And in signal, race conditions can be really hard to debug because they often depend on timing that varies each time the code runs. One way to handle this is by ensuring that dependent operations are properly synchronized.
But how do you synchronize them without making everything synchronous again?
Good question. You can use promises or async await to control the flow more precisely. For example, if one operation depends on another, you can chain them using then or await.
That makes sense. But what about cases where multiple operations need to finish before proceeding?
In those scenarios, you can use promised all. It takes an array of promises and waits for all of them to resolve before moving forward. This ensures that none of your dependent logic runs until all required steps are completed.
So, promise all would help ensure everything is done in the correct order?
Precisely. And if any of the promises reject, promised or will immediately fail with the first rejected promise, so you can handle errors centrally.
That sounds like a solid approach. I'll definitely try using promise all to manage those kinds of dependencies.
Absolutely. It's very useful for coordinating multiple asynchronous tasks. Just make sure each promise represents a distinct operation, and that their results are independent unless explicitly chained together.
Makes sense. I'll give it a go and see how it works out.
Great! And if you run into specific cases where things still aren't working as expected, take a closer look at how data flows between these async operations and check if there are implicit assumptions about timing that might be causing issues.
Will do. Thanks for the advice. It's reassuring to know there are ways to tackle these problems systematically.